Hello viewers, today I am going to include one more video on my playlist MATLAB uses tips and tricks. In this video I am going to give you a tips that how you can check the computational limitation of the MATLAB, because once you are using this software and you must actually know the limitation of this software first. So I'll start with the topic computational limitation. Since you know that MATLAB works under IEEE double precision standard. In this standard, it takes 53 bits in the mantissa and 11 bits in the exponent. So it is almost in the range 10 raised to power minus 308 to 10 raised to power 308. So if you wish to check whether you are doing the correct calculations and your limitation range, you must write real max. When you click on it, you can see that this is actually the upper limitation. This e doesn't mean that a logarithmic base e, it actually the exponent means 10 raised to power 308. If you wish to say the lower bound, so this is 2.2251 into 10 raised to power minus 308. It means if your calculation exceeds 10 raised to power 308, so you will get the answer infinity. If in other words, if I say 1 divided by 0, it will give you infinity. The notation is INF, and if 0 is divided by 0, it means it's not a number. And obviously, if you wish to check your the computational limitation, like if you are doing some calculation which is very big, is of the order of like 2.5 into 10 raised to power, you can say that e raised to power, e positive you can use like 200. So this is your variable x and this is saved in the workspace. And if you wish to check for the y, like it's let's say it's 1 into e plus 200 also. Yeah, this is actually the y workspace. So the size is very big, 10 raised to power 200. Yeah, doesn't matter. If you wish to add or add, then it's okay, but if you wish to multiply this, so what the answer is? Answer is infinity. Your answer should be 2.5 into e raised to power 400, but answer is not that, because you are beyond the limit of 308. So you don't have the range in the MATLAB so that you can do the calculation more than 10 raised to power 308. So this is the one of the limitation in the MATLAB. The another limitations, you know that, and this is actually not the limitation. This may be the errors done by you. Like if I talking about the syntax you are using while calculation, like if I say that I'll clear this first, CLC, and clear all. Yeah. If suppose you are wish to divide 3 with 4 and multiply 5, so what will be the solution? So this is the important thing you should keep it in mind, that once you are writing this all syntax without using the parentheses, so it will read like this: 3 is divided by 4, then multiply by 5, not the other way. Like answer is this, the answer will be the same like if I this one 4 multiply 5, the answer is the same. But if you are using other way, like 3 divided by 4 multiply 5, so answer is something else. So it is for the reading from left to right, so keep it in your mind. Say what is the solution of 1 minus 5 to 0.2? So what will be the solution? Solution will be 0. The answer is correct. If you are using this syntax 5 into 0.2, because of the error by conversion to the binary, 0.2 will be the converted to this type of binary system. Like if I say that, if you convert it, you can say that this type of binary up to so on infinity, this type of binary system is actually being used by the MATLAB. So the answer is correct, because you are multiplying the error with some with 5, your solution it will automatically reduce to 0 with some approximation. So with the approximate, the answer is less. But what happen if you do like this, the same thing like this? As I told you earlier, the MATLAB will do the calculation from left to right, and what will be the solution? The solution, when you enter it, it will give you this. The same thing I am written in another word, but the solution error is there. It is only 0 10 raised to the minus 17 accuracy, because the accuracy is not very much deviated, but still it's not giving the 0. The problem is that the conversion of 0.2 and the approximation used by MATLAB, it will not give you 0 if you are using this type of syntax. So you must be aware of this first, and once you do the calculation, you must take care of all such things. So this one more thing, you can must learn the short e, which is called the exponent. Like if I am dividing 1607 with 78, it will give you answer like 4 after 4 decimal. It's just for the displaying of the digit. The calculation we done is the same, but displaying this is only the 4 decimal. Instead of this, if I use the format long and do the same calculation, it will give you the 14 digits after the decimal. And similarly, there is another format like format short e and format short long e. So this is the several formats you can use. There is another format which is important, you can use it, format short g. This is actually like handling when the digit is very large, more than thousands of thousands, like you can say that more than the 1000. So it will use the exponent version, otherwise it will give you this type of format. So short is, if you are using the 2 decimal, you can also use the format bank. If you are using the same thing, so it will give you only the 2 decimals, like you can say 2 digits after the decimal. So this is the important thing you must keep it in mind with doing the calculation. So this is all about of the computational limitation and the displaying of the digit. So hope you like this video. Please subscribe to my channel Scientific Rana. Have a nice day.